Hello, today we're going to be doing Pythagorean Theorem. This is actually a very famous theorem. Everybody knows it. The equation is a squared plus b squared equals c squared. And I'm pretty sure you're going to get sick and tired of hearing this throughout your math career, but it's a very famous theorem. And believe it or not, we found out this really early on in mathematics, and it was a huge milestone. Um, so we're going to be doing some pretty cool things. Okay, now, I'm actually curious. I wonder if I should do the proof of the Pythagorean theorem, because I know one proof, and it's actually kind of like it's actually kind of cool, but it's a pretty um, weird looking proof. It uses squares along. It's basically constructing squares along this side, which is a c square, and then you're going to do a square on this side, and you have to do angles and line. It's actually pretty cool, but it's actually a really cool proof. I'm not sure if I should do it for this video, but maybe for a future video. I'm not sure. I think I should do it. I think it's pretty cool to uh, to know it. Okay. Um, Basically, what we're doing is A and B is the legs or the sides of the right triangle. Oh, this is okay. In order to use a Pythagorean theorem, it needs to be a right triangle. You cannot use this a formula if it's not a right triangle. That's a key thing. And okay, I just wanted to make sure that's clear. Okay, so there's two legs and a hypotenuse for a right triangle, and A and B is it could be either leg. It doesn't matter which one. A this could be A. This can be B. It doesn't matter. It's still the same. You square the legs, and it will equal the hypotenuse, which is the opposite side, or which is like the longest side of the triangle. Um, it's directly across from the right triangle. So you see how this is right triangle? It's the opposite side, which is over here. It's making that length. So over here, it's making this length. So it's the longest side, the hypotenuse. Here's how we're going to be using it. We have this right triangle. We say that this is A and this is B. So we square both of them. And we get 9 plus 16, which is 25. We square root both sides. And this equals 25, or is the square root of 25 is 5. So yeah. A little side note, it doesn't show there, but technically it should be, but it doesn't make any sense. I'll show you what that means. Um, Whenever you take the square root, or let me actually use what they were using. Whenever you square root both sides, you're trying to the squaring and the square root is a cancel. They're opposites. They're canceling each other. It's like you, uh, it's best way to say it's technically the inverse of each other. It's like someone saying like, oh, I'll give you $2, but once I give you the $2, you have to give me back the $2. It's basically the opposite. It never nothing ever happened, so it gets rid of it of me doing the transaction. So all you're left with is back to your original. So in this case, okay, it's c squared. Okay, you square root both sides, but whenever you square root both sides, you're supposed to do a plus or minus, because I'll show you why this is. This is so it should be plus or minus 5. C should be equal to that. But all it says right here is just 5. Now, the reason why it's plus or minus 5, okay, let's just plug it in right here. Let's do 25. Okay, you're squaring positive 5, which is just 25. Now, what if you do negative 5? Yeah, negative 5. Well, a negative times a negative is a positive. So this negative will go, it will cancel out, or not, well, a negative times a negative is a positive. And this will become also a 25. So a positive 5 and a negative 5 will always work. But look at the contents, or the context that we're looking at it. We're looking at distance. The reason why it's distance is because look, it's centimeters. So if there's 3 centimeters here, 4 centimeters here, and then we put a negative 5 centimeters, how can we have negative distance? It's like saying, oh, if I go, it's not like velocity where there's a negative, but velocity has a direction. Okay, you start from this point. Well, what if I go this way? You know, say that I walk 5 meters this direction. Well, if I walk the opposite direction, the same distance, 5 meters, is it negative 5 meters? No, you're only looking at the distance. This distance is still 5 meters. There's no negative distance. So this is why they didn't put the negative, because we're talking about an actual distance. And distance is never negative. It's only 0 and up. So that's just a little comment that I feel like I needed to address. Sorry, it took a little bit of explanation. Okay. Now let's do the actual work. Okay, we're trying to find the length of the hypotenuse on each triangle. If necessary, round to the nearest tenth. Tenth means all the way to 1 decimal point. So whatever the decimal point is, say that we have some number here, we don't care that number, it's going to be point some question mark, whatever this number is. That's what we're rounding to. And what we determine that round is by, if there's more numbers here, we look at the next number. If it's greater than uh, 5, then we round this one up 1. That's how we do it. Okay, now let's see. We have, for problem 1, we have this right triangle. We have 5 inches. Remember, we have to take into account inches. Okay. Now we use a formula. I'm going to constantly refer back to it. What's our formula for the Pythagorean theorem? Is a squared plus b squared equals c squared. This is our c. It's always the hypotenuse. It's the longest side. It's directly opposite or of the angle of the right, or the 90-degree angle of the right. The 90-degree angle of the triangle, which I am terribly sorry. My mic cut off. It lost power. I am charging it right now. Okay. We could put any. We could say this is A, this is B. We can say this is A and this is B. So, um, oh, we could choose anyone. Let's just say that this is A. So we have 5 squared. We technically could put, if we want to be formal, we have to put inches uh, as for our unit measure. I'm just going to do that. But when we square it, we just don't put, this is our 5 squared is 25. We don't put just inches. We put inches squared. That's our unit of measure. So, let me see. Okay. So we add these up. What do we get? 100 plus 25. That is 125 inches squared. So this is our c squared. Now we have to square both sides. Square root both sides. Those cancels out. So all we're left with is c. Now we have to square root the entire thing. We square root the inches, which is just inches to the second power, which will cancel out. So all we're left with is inches. And what's the square root of 125? It is 5. So we have 5 inches. Or whoa, 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 whoa. I was thinking about one. Oh, whoops. Oh, that was a big mistake. Whoops. I was thinking about the cube root, not the square root. Oh, be careful. The cube root of 125 is 5, but the square is something way different. It is, let's see, 11.18. We round to the nearest tenth, which is this number. So we have to look at the next number, which is 8. Since it's higher than 5, or if it's a 5 or higher, then we round this one up. So it's 11.2 inches. That's our C. So C is 11.2 inches. Yeah, whoops, that was a big mistake. I was like, oh, not the cube root. Even I make mistakes, it's okay. Okay, now the next one. Okay, let me just show you. See how this one has a right angle and this one doesn't? Technically, we cannot say that we can do this, the Pythagorean theorem, unless we know that this is a right angle. But we do not know it's a right angle. So technically we can't make that assumption by this triangle, because this can be like a bent angle. This can be like this could be 89 degrees, not 90. It almost looks 90 or whatever. But yeah, we cannot make the mistake. But we, for this sake, we're just gonna assume that it is. So it doesn't show here, but I'm just gonna make the right angle right there. So we're gonna have 8 meters and then 15 meters. So this is our C. Again, what's the formula? A squared plus B squared equals C squared. We can set this to be A, or this to be A, and this one B, this one B. It doesn't matter. Either one it could be. Let's just say that 8 is our A. Say that this side is A and this side is B. So we have 8 and then our 15. We have 64. I think this is 215. This is what happens when you don't know your squares. Oh, 225, my bad. I was just off. I was close. But, you know, it's okay. Okay, now we have 225 plus 64 is 289. Now we have to take the square root on both sides. This will just become C. What's the square root of 289? I have no idea. Oh, it's 17. Oh, if I knew the square root or the square of 20 or 17, I could have done that. I would have known. Remember, we're using in meters, so this is in meters. So this is 17 meters. Okay. Let's just do another problem, might as well. Let's do there. I know the answer for this. Okay, what's the Pythagorean Theorem formula? It is a squared plus b squared equals c squared. Let a be 5, 12 be b. This is 144. This is 25. This is going to be 169. Square root both sides. This should be 13. We can do the calculator. Let's just do it. 169. It is 13. We do not need to round. And this is actually a Pythagorean triple. Same thing with this. This is also a Pythagorean triple. What is a Pythagorean triple? It's basically when you find a combination of numbers that satisfy this equation that are perfect numbers, or I mean like are natural numbers, where there's no decimals. Like for instance, this has no decimal, but this one does have a decimal. So this is not a Pythagorean triple. It's just a special name for it. Okay, let's see. Next one. Okay. This is just exactly the same thing, but we're giving new information. Okay, yeah. We're just giving it in a different way. I thought it was like a different thing, but okay. Yeah, it's just a different way of looking at it. It still wants you to find the hypotenuse length. It gives you the two legs. I thought this was the 8 feet hypotenuse. I thought we were trying to find the other leg, but no, these are the legs itself. Yeah, they give you in a different format. So imagine like this, if they were to say this, okay, the legs were 5 and 10 inches each. So, and then this one was 8 and 15. So, and then find the hypotenuse. They don't give you the picture. They just do it in a different way. So let's just, well, we just kind of, I like to see a picture. So let's just do, okay, the legs is, let's just draw a triangle. So they said one leg is 6 feet. And then the other leg is 8 feet. So we're trying to find the hypotenuse. Now let's do the equation. I think it's not 3. This one says 3, but I actually did a problem 3. I'll just write down 3 for this one, so it matches this one. That could be like 2.5 on the other one. Or the other problem, the previous problem that I did. What is the formula? A squared plus b squared equals c squared. A and B can be either leg, so let's just say A is 6. Let me actually write down the units, because we didn't do the units for the other two. Remember? When we square the 6, we got to square the units as well. So it's going to be 36 feet squared, or square feet. So this is 64 feet squared, or square feet. So 64 plus 36, it is 100 feet squared or cube feet. This is going to be square root on both sides. Boom, boom, because they cancel out. Remember, we have to square the feet, or the feet squared. So the square root is the opposite of squaring something. So the square root of 100 is 10. This just becomes feet. There we go. So 10 feet. There you go. And then let's do number 4. We are given the legs is 12 and centimeters, and then the other leg is 5 centimeters. Let's do this. Draw the picture. You don't have to draw the picture, but I like drawing pictures. It makes it easy to see. But technically you don't need to. You can just put it in the formula, but I like the association of the picture and the formula, so I visually see what's going on. Okay, so let 12 be A. And 5 be B. Oh, whoops. If you recognize the problem that I did previously, you would know the answer. I just realized it right now. I was like, whoops. Square root of both sides. We actually did it. Whoops. This is actually 13. Whoops. 13 centimeters. This is a problem that we did on the previous. This is actually a very famous set of numbers, so that's why I used it on the other problem. I just wanted you guys to be exposed to it. Yeah. Okay, let me see, what else do I have to do? We have more problems to do. Let's see. Okay. This is just the same as before, but instead of giving the 2 legs, we're giving the hypotenuse and one of the legs. But we could still solve it because it's one equation and one unknown that we're solving for. Okay, let's do it's continued. Okay. Basically, okay, yeah, let's just follow this example. This is still the C. C is always the longest side of the hypotenuse, and this can be either A or B on the legs. In this case, they set 6 to be A, so this is A, and this is B. So we're trying to find out what is B. So they put 6 squared is 36, 10 squared is 100, and they move it to the other side. It's going to be 64. And then they square root both sides. Square root of 64 is 8. So B is 8. So this side is the length of 8 centimeters in this equation. Let's do an example of that. Let's just do another one. Let's say that we have this 10, 16. Okay, let's do this. Meters. Okay. What is our formula? It is a squared plus b squared equals c squared. What is our c? Our c is the longest side, which is 10 meters. Okay, so we put 10 for c, and then we could say that this is a and this is b, or this is a and this is b. Let's just say that this is A and this is B. So we just leave A as A plus 16 squared. What is 16 squared? It's 2 something, 250 something, I think. 256, yeah. This is 100, A squared. Now we move it onto the other side, or actually, this is where, oh, I actually made a mistake. Okay, I made a classic mistake. I was just making up numbers. This is what happens when you make up numbers. Um, you get a mistake. Remember how I always said that the hypotenuse is the longest side? Look at what I did. I put 10 meters and this is 16 meters. So is this the longest side? No. This is the longest side. So this is not a right triangle at all, which means that this formula does not work. So this is a failed example, but we could just change it. Let's just make this 10 and this 16 to make it work. Whoops. This is what happens when you make questions on the fly. You forget simple things. Even I make mistakes. It's fine. Everybody makes mistakes in math. This will become 156 a squared. Now, this is not going to be a perfect square. It's going to be like 12.2 or something like that, or 1.5 or something like that. Let's just do square root of 156. This is 12.4. Okay, I was a little off, but it's okay. 12.489. Let's just round it to the nearest tenth, and this is 12.5 because this is our 10th place, and then we have to judge, is this 5 or greater? Yes, it is, so it's rounds this one up 1. So 12.5 meters. So A is 12.5 meters, approximately. Now, let's see. Okay. We are given this triangle. It's still a right triangle. It's just tilted. Let's see. Let's draw it out. Notice how I always like to draw it like upward or correctly, like upright. It just makes it easier to see. This is 50 feet, 40 feet. Now we have to use a formula. This is a right triangle. This is the longest side. And notice how this number is definitely bigger than this. So we're not going to have the same mistake as before. Okay, this is our C. This can be our A or B. Let's just say that this is our, we said the other one was A, so let's say that this is B. And this is A, so we're going to solve for A. So, or actually, no, other way around. This is B. We need to solve, wait. Oops. This is B. This is A. I always do A, B. I don't know if you notice in the problems that I do. I always put this as A and this one's B. It's just a habit of mine because I usually reserve A or B for the base. It's just a habit that I do. So I confuse myself when I put, oh, this one's because I wanted to solve for B, and then the last time that we did what this was, yeah, it confused me a little bit. But yeah, so let's figure out our B. I just confused myself. Sometimes it's better to take it slow. So our A is 40. B is just B. And C is 50. 40, I do not know what that is. That is 1600. Oh yeah, I could have done. Oh my god, whoops. I could have done that in my head. And this is 2500. Let me show you there's a trick. Notice how. Well, what's 50? Well, 50. The reason why I was like, oh, I could have done it in my head if I was just, use my head instead of using a calculator to do um, the work. I should use my brain. Think about it first. Uh, okay, what's 50? Well, 50 is 5 times 10. Okay, but we're squaring both the entire thing, so we have to square individually. So we square this number and this number. This becomes 25, and this becomes 100. So we got 25 times 100. So we just have to add the 2 zeros on the end of it, which is right here, 2500. Boom. So if I was just smart, I could have just done that in my head. But I didn't need a calculator. There's an example. If we just use our head, we could solve our problems easier. So we have 90. Oh, here's an example. We have 900. Let's do this with the outer calculator. What's 900? We don't need a calculator. We don't need it. Just put it upside down. Who cares about the calculator? Let's do 9. Well, what is 900? Well, that's 9 times 100. Well, if we're going to be square rooting the entire thing, we have to square root this entire thing. And there's a property. Whenever I square root a product, I can square root them individually. This only happens when there are a product on the inside. Say that there was a plus 1. This now becomes this. No. This does not become that. It's only when there's a product, when you're multiplying. So this does not happen. This is a no-no. So we could split it up. This becomes a 3. This becomes a 10. 10 times 3 is 30. So B is 30 feet. There we go. Let's just confirm. And boom. See? We don't need a calculator to do our work. This is a neat little trick that you can use to break it down and make things simpler. Just in case if you don't have a calculator. Now let's see. Over here. Well, this one is just a word problem that we can do. Okay. Visual. Let's visualize what's going on. Okay. We got a 12-foot ladder. Okay, so we have a ladder, but it's leaning onto it. So we have a 12-foot ladder that's lean. Okay, let's just. This is you. You're trying to like set up your ladder. This is a ladder that you're trying to lean against. On a window, there's a window right here. And the ladder is, okay, it's okay. Well, the window's on a wall. It's not just hanging off of the wall. This is a 12-foot ladder. And it's leaning, the bottom of the ladder, or at the base. That's why you use the word B for base. is 3 feet away from the wall. This is the wall right here. So this is 3 feet and this is 12 feet. So you could see how high the window, or how high up uh well in this case, so where the window is, it's at the edge of the ladder, but like in the window can be higher or lower, it doesn't matter. But anyways, you can see how high the ladder goes up the wall. It will go up to the wall up to this point right here. So we need to find out this length right there. So I don't know about you, but usually whenever I think of a wall, it's straight up. So whenever it's straight up, you can think of this as a right angle, because unless it's slanted, then you can't do this. But we're just thinking of a regular wall that's going straight up. Okay, so we use our formula. A squared plus b squared equals c squared. So what is our c? It's the longest side, it's the hypotenuse, which is the length of the ladder, which is 12 feet. What? Oh, well, we said the bottom is a base, so I'm just saying B for base. So this can be our B. So we need to figure out our A. So plug in what we know. We know what our B is. We know our C. We just do the problem. So we square root both sides. I do not know what this is, but it's going to be very close to 12. It's going to be like 11.5 or something like that. Okay, 11.6. We're just round to the nearest tenth because that's what it says. 11.6. What is the next number after the 10th place, which is this? It is a 1. It is not 5 or higher, so we just keep it at 6. So it's going to be 11.6 feet. So this height is 11.6 feet. There you go. Let's see if there's more. Yes, there is more. Okay. This is going to be a longer video. Longer than I wanted, but it's all good. Okay. We are... Okay, yeah. This is like, you know how I mentioned prior in the video, in order to use the Pythagorean theorem, we need to know that it is a right triangle. And then I believe I mentioned prior, you see how this did not have the right angle indicator? Well, these don't have the right indicator. So like here's an example of what I was saying earlier, that we do not know that this is a right triangle. We assumed at the time, but you're not always allowed to just assume that it is a right triangle. The only way that you know it's a right triangle for sure if it has that 90-degree angle. And these don't, so we can't assume that these are all right triangle. In order to use the formula of the Pythagorean theorem, we need to know it's a right triangle. And so if we to go backwards, if we use the formula and if it doesn't make sense, then that means that it's not a right triangle, because we can only use that formula. It's like, okay, we know it's a right triangle. So this means this, or the Pythagorean theorem, a squared plus b squared equals c squared, it will work. It will work. So if we to go backwards, if we are given just a regular triangle, not knowing it's a right triangle, if we use this formula going backwards, if this, if we plug it in and if it doesn't work, then that means that this does not, or this means that this is not a right triangle. So we're just like going backwards. Um, it's like another way. It's actually a proof. I think it's a contrapositive. I think that's what it is. It's a type of proof. It's like if it is a right triangle, or no, if it satisfies the Pythagorean theorem, then it is a right triangle. But uh, if it doesn't satisfy uh, the Pythagorean theorem, then it is not a triangle or right triangle. So I think that's how it works. But yeah, basically we have to see if it works. So in this case, let's use this example. We set our A, B, C. Okay, well in this case they put 4 as B and 3 as A. See, I like to use my B as the base of the triangle, but it doesn't matter. They did the squaring. Okay, 9 plus 16, 25. Yeah, this seems all correct. So it is a right triangle. So we can put this little right triangle there. So that is true. This is a right triangle. Now let's determine these ones are. Let's see. Let's do the first one. First one is this. We have 6, 9, 15. They're all inches. We do not, this is what we're trying to figure out right there. Is this a right triangle? Is there a right angle right there? We do not know. Let's see. Use a formula. A squared plus b squared equals c squared. Let a be 6. 9 be b. And then 15 BC. So we have 36 plus 81 equals 225. So we have, add these up. This is going to be a 7. This is going to be 1. Wait, yeah. Is it? Wait, yeah. 36 plus 81. Yeah, it's 117. Yeah, I got it. Yeah. This is not equal that. So this is not a right triangle. So the Pythagorean theorem won't work on this. So if we were missing this thing, we can't use the Pythagorean theorem to figure out the other length. We have to use some other formula or other ways of finding it. I would discuss how to figure that out, but I can't. Not in this class. Okay. We have next, let's do this. We have 4.5, 2.5, 11.5. Let's do our a squared plus b squared. Let a be 4.5. Okay, yeah, I'm gonna have to use my, I don't want to be sitting here and trying to do it by hand, but yeah. This is going to be 20.25. And then this is going to be 62.5. Okay, now we're going to do 11. I can tell you that this is way off. What is 20.5? This is not equal to that. That's way off. So this is not. So this is not a right triangle. Now let's do this. Okay, yeah, it is. This is actually a special triangle or a special set. This is actually a Pythagorean triple, if I remember correctly. Why I remember this? I don't know. I do this. I've done math for a while. I just gotta remember numbers, and yeah, it kind of just sticks with me. Let A be any of these two legs. We're trying to figure out, is this a right triangle? Let's figure that out. Okay, well, let A be 21. This will be that. C be 29. I don't know what that is. 21 squared. That'll be 141. This will be 400. I don't know what 29 is. A 41. Yeah. This is 841 equals 841. This works. So this is a right triangle. Yes. There you go. This is actually a Pythagorean triple. And yeah, that's it for this. I hope you learned quite a bit. If you have any questions, please let it in the comments below. Hopefully I'll answer as quick as possible. And thanks for watching.